Hello my dear students, this is Akash HD. Welcome to the ASD Physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter straight line motion. In this question we are going to see how from this question we will draw the velocity time graph and how this velocity time graph will be useful to calculate the maximum velocity and the total distance traveled. Okay, so let's start the video. Question came in a JEE 2021. Let's go to the question. A car accelerates from rest, keyword is from rest, at a constant rate alpha for some time, okay, after which it deaccelerates at a constant rate beta to come to rest. Now see, if the total time elapsed is t, okay, seconds, calculate the maximum velocity and the total distance traveled by the car. So here when you will see the question very well, kindly see very well. Car starts from rest and again come to rest. Now, so when we'll draw the graph here, anyhow, here what will happen that here, it will start from the rest. That means here velocity 0, this is the velocity time graph. And here also at the end also what is there? The velocity is 0. Okay, and anyhow this is the origin. What is this? This is the origin. Now after that, if you will talk about the question, they are telling that here, velocity is increasing with uniform rate. That means acceleration is uniform and the velocity time graph will be straight line. Okay, so what is happening? Let's take from O to A. From O to A, what is happening that here? Uniform acceleration is there, alpha. Okay, and here what is this? This time is t1. Now this time they told now some time is there. Let's take time taken during the acceleration. This is the t1. Now I have supposed. After that, what is happening that here, it will reach to the maximum velocity. This is the maximum velocity, okay. And after that, what will happen that here, it will start deaccelerating. That means the brakes are applied. O to A, accelerator, but A to, we can tell here when it will come to rest, what is applied? Brakes are applied. So in this situation, what will happen that here, if in case the velocity is positive, acceleration have to be negative, is it? Because you know very well, when this velocity and acceleration in same direction, what will happen in this situation? Velocity will increase. And when, let's take velocity in this direction, but acceleration in opposite direction. So what will happen that here, in this situation, velocity will decrease. So O to A, this is the situation. After that, A to B, this is the situation, both in opposite direction. So anyhow, here velocity positive, acceleration positive. Here velocity positive, but acceleration negative. Okay, but the magnitude of the acceleration, how much is given here? Beta. Okay. And one more thing, please remember that here. What I am going to tell you, remember that here. This is the, anyhow acceleration is positive, so mod of alpha, I am writing alpha. And this acceleration, beta is negative, okay. So mod of minus beta, anyhow, I will take in here beta only. Na? That means I am just taking the magnitude. What I am taking? I am just taking the magnitude is there. Now, because question we have to solve in a very, very clear manner. Okay. Now after that here, during the deacceleration time, let's take the time taken is t2, but in the question they have given total time. How much here? Total time is t. That means from here to here the total time is t. Okay, and after that what we have to do? The first thing I am going to calculate the maximum velocity. Okay, so for the maximum velocity, what I am going to do? I am going to use the concept of a slope. That means the slope of velocity time graph gives the acceleration. Okay, and one more thing, I am telling now this alpha is positive, so here slope will be acute angle tan theta, and here I am telling that this beta is negative, so here let's take phi, this is the obtuse angle. This is B, this is beta, don't be confused. Okay, so what is happening that here, if I talk about here O to A, so O to A, acceleration is given by, acceleration means slope of this graph O to A, is it? So here slope will be what here, we can tell opposite by adjacent here, even triangle is there. This opposite is the V max, adjacent is T1. So I can write here alpha equal to V max by T1, is it? Or from here later I will use here T1 is given by V max by alpha. Okay, V max by alpha. Okay. Similarly, if I talk about here the beta, again I am telling this beta actually negative, but I am just taking the magnitude. Okay, so this beta is given by what here? Again opposite by adjacent here. This opposite V max and adjacent is what here? T2, is it? V max by T2, just magnitude we are taking. Okay, so beta is V max by T2. Okay, so from here T2 will come what here? T2 will come here V max by beta. Is it? Up to this is okay. Now what I will do here, again you know that here total time is what here? Total time T1 and T2 is what here? T, is it? So we can write here, see, this T1 plus T2 is equal to T. Now, so what is the T1 here? T1 I can write here, see, V max by alpha. T2 how much here? I can write here V max by beta is equal to T. Is it? Can you see? Very well. Okay, we are calculating the maximum velocity. After that, when we'll go to the next one, what we can write here, see, this V max will be common, so we can write here 1 by alpha plus 1 by beta is equal to total time is T. Next one, just take here the LCM. So when I will take here the LCM, it will come here alpha beta, and here we can write here beta plus alpha is equal to T. Is it? So hence this maximum velocity, this maximum velocity will come what here? We can write here, see, this alpha beta by alpha plus beta into T. Okay, even sometimes they are giving some numerical data, and then directly we have to use this formula. Maximum velocity how much here? Alpha beta by alpha plus beta into T. Is it? So one part is complete. Now after that here, if I talk about here the second part. So in second part, what is happening that, remember that we have to calculate the distance. You know very well, all means if we see the graph, this graph is above the time axis. There is no part below the time axis. So in this situation, distance and displacement both will be positive. Or we can tell distance and displacement both will be equal actually. Because see, even because you know very well, the slope, not slope actually, the area of the velocity time graph gives the distance or displacement, but here you can see full area is above the time axis, no area below the time axis. So anyhow the distance and displacement both will be same. Object is moving in a straight line without changing direction. Okay, so we have to take this area to get the distance. So remember that here we can use the formula here. What? A triangle formula. What is the triangle formula? Half base into height. Is it? So half base how much here? T. Height how much here? V max. So directly I can write here half T into V max here. Is it? So just see here. Now, so distance or displacement I am telling both will be equal, and that is S. So half base into height. Half base is T, and height is how much here? Height is V max here. Is it? That means we can write here half into T, total time T. V max how much is there? See, we can write here alpha beta by alpha plus beta into T. Is it? So when I will simplify this, this will come here, this S equal to half alpha beta by alpha plus beta into T square. Okay, so this is the maximum velocity, and this is what? This is the distance, or even we can tell displacement also. Can you say very well? And even remember both this formula also directly can be used in a question. Okay, so students, anyhow, just this also kindly say very well. So students, I hope so this conceptual video in which we have learned how much this velocity time graph is useful to calculate maximum velocity and distance, or sometimes displacement also. Okay students, so keep studying, keep growing.